Okay, we're going to hope that we got to here in class. So we've looked at graphs, we've looked at tables, and so now we're going to look at equations. And so it says the derivative of a polynomial function is given by this equation. Use this equation to answer questions 16 through 20. On what intervals is it? Increasing, decreasing, justify your answer. So again, notice that they give us the derivative here. I know that's kind of blurry. And so if they give us the derivative, what do we want to do? We want to think about where the derivative equals 0. And so very nicely, it's already factored for us, right? So the derivative is going to equal 0, at 2, and at -3. So I'm just like, they did the hard work for me, right? So if I'm trying to figure out where it's increasing and decreasing, right? I'm just going to kind of make my little table here and think about what's happening on each side of that. So again, I'm going to plug in numbers up here, and I'm just going to kind of do the math. If I pick a number smaller than -3, like -4, then the x is going to be -2 minus -3, that's going to be positive, and -4 plus 3 is going to be negative, and so a negative times a negative is a positive. Yes? So that's increasing. If I pick a number between 0 and -3, I'm going to pick -1. So -1 is going to be negative. 2 minus -1 is going to be positive. And -1 plus 3 is going to be positive. So that's going to be negative, which means the function is decreasing. If I plug in a number between 0 and 2, I'm going to pick 1. So that's going to be positive. 2 minus 1 is negative. 1 plus 3 is positive. So that's also negative. Did I do that right? 2 minus 1 is positive. Just kidding. That's positive, right? See, it's bad when you mess up. And then if I plug in a number bigger than 2, like 3, that's going to be positive, negative, positive. So that one's going to be negative. Do you agree with that? See how easy that is to mess up? So that's kind of all my work. And now I'm going to just say what's happening. So I'm going to say f of x is increasing from -infinity to -3 and from 0 to 2. Why? Because f prime of x is greater than 0. That's all I have to say. And I'm going to say, oh, I wonder if that cut off. I'm going to start over here now. F of x is decreasing from -3 to 0 and from 2 to infinity. Why? Because f prime of x is negative, because it's less than 0. So 17 and 18, we can do the same thing using the same work I've done. Where does f of x reach a relative minimum? Relative minimum at x equals what? Minimum is going to be when it changes from decreasing to increasing. So that's going to be at x equals 0 because f prime of x changes from negative to positive. And a relative maximum, I think there's 2 of them here, right? Relative max at x equals -3 and x equals positive 2 because f prime of x changes from positive to negative. Okay? Now look at the next one. It says, if f of 4 equals -1, what's the equation to the graph of the tangent line at f of x equals 4? Well, if I want a tangent line equation, what do I need? I need a point and I need a slope. They're giving me the point right here, so I need the slope. I need to find f prime of 4. And guess what? They gave me f prime of x. So I just have to plug in 4 into that derivative, and I can get the slope of that tangent line. So f prime of 4 is going to equal 4 times -2 times 7, or -8 times 7 is negative 56. Do you agree with that? So what is the equation of the tangent line? This is my point, right? So y minus negative 1 equals my slope times x minus my x value. And again, I'm going to leave it like that unless it tells me to do something else. So look at number 20. It says approximate the value of f of 4.1. If f of x is concave down at x equals 4, is this an over or under approximation? And so I wonder if before number 20, if we've talked about concavity. Sorry, I'm just looking back here for a minute. Okay, so I'm going to talk about this for a minute and see if it makes sense or not. So if this is my tangent line, just like we said before, we can approximate f of 4.1 by using my tangent line equation. So I'm going to rewrite this. I'm not going to work it out, but I am going to write it like this and subtract 1 over. So now in my tangent line, I'm going to just plug in 4.1. And you would want to be able to do this without a calculator. So think about this. 4.1 minus 4 is 0.1. And if I multiply that by 1/10, that's negative 5.6 minus 1. So that's negative 6.6. Approximately. It says if this graph is concave down. So here's what concave down means. Concave down would be like this. Concave down means the tangent line is drawn above the graph. Concave up would be like a parabola opening up, and the tangent line is below it. So based on whether it's concave up or concave down, tells you whether it's an over approximation or an under approximation. So concave down means the tangent line's above it. So this would be an over approximation because the tangent line is above the curve. And I wouldn't know this if it didn't talk about whether it was concave up or concave down. Okay? Okay, where's my time? Okay. So, look at the rest of this here. Says, picture to the right of the graph of p prime of x. So again, this is the derivative. Really important to pay attention. Are they giving me the function or are they giving me the derivative? Use the graph to answer the questions 21 to 25. So again, think about given the graph, where is the function p of x decreasing? P of x is going to be decreasing when p prime of x is what? Less than 0. So looking at my graph, I'm going to scoot this over just in case it's cut off a little bit. That would be where it's below the x-axis. So that would be this whole part of the graph. So that would be on the interval -3 to 0 and 0 to 3. So sometimes if you're not sure, like do your justification first and then maybe answer it. So like the next one says, where is p of x increasing? Well, p of x is going to be increasing when the derivative is what? When the derivative is greater than 0. So that's where it's above the x-axis. So that would be these parts. So that would be from -infinity to -3 and 3 to infinity. Look at the next question. It says, at what values of x does the graph of p of x reach a relative maximum? Justify your answer. Well, relative maximum occurs when the function changes from positive to negative, when the derivative changes from positive to negative, right? So think about, like, look at our zeros, right? Look at this 0. To the left of it's positive because it's above the x-axis, and then it changes to negative. But at this one, it's negative on both sides. And at this one, it's negative to the left and positive to the right. So where's the relative max going to be? Relative max at x equals -3 because p prime of x changes from positive to negative. Where's the relative min occur? Over there at positive 3, right? For the same reason. So the relative minimum occurs at x equals positive 3 because p prime of x changes from negative to positive. At 0, nothing. It's not a max or a min, right? So look at the next one here. It says approximate the value of 1.8 using the tangent line at the point 2, negative 3. So again, they're giving me my point of tangency. So the other thing that I need to do is I need to find my slope at 2. Again, remember this is the graph of the derivative, right? This is p prime of x. So p prime of 2 is just going up here on the graph and figuring out what the point is. So p prime of 2 is negative 4. So then my equation is just going to be y minus negative 3 equals my slope times x minus 2. And again, if I want to write it so I can do a tangent line approximation, I'm just going to subtract the 3 over. So to approximate p of 1.8, I'm just going to plug 1.8 into this problem. Again, without a calculator, you should be able to do this. This would be negative 0.2. Negative times a negative would be positive 0.8 minus 3, which would be negative 2.2. Do you agree with that? That's the approximate value of that. Do I know whether it's an over approximation or under approximation? Not yet, because I don't have a, what's it called? Concavity. If you look at the next stuff, it's the homework. There's a good amount of stuff here, so you're welcome to get started, jump around and do some that you feel good about, or wait in class, but there's a lot here. This is the last assignment before the review.